So X-rays really shows us that the universe is very energetic.
We find X-rays in jets, erupting from the centers of active galaxies. We use them to measure the spin of black holes or supernova explosions. It takes a powerful event to produce cosmic X-rays.
Sometimes people also call it the hot universe because, when you have this gas in galaxy clusters or also around galaxies that you can see only in X-rays, this gas is about 10 million to 100 million of degrees, which is so hot that this gas does not radiate in optical, does not radiate in infrared, but it only radiates in X-rays.
To further understand these hottest regions, we need the next generation X-ray telescope. The Japan Aerospace Exploration Agency, or JAXA, is partnering with NASA and the European Space Agency to launch the next generation X-ray space telescope. The telescope, called XRISM, launches from the Tanegashima Space Center at the southern end of Japan on an H-IIA rocket. The spacecraft weighs over 5,000 pounds, stands over 30 feet tall, and will orbit approximately 340 miles above Earth. We're familiar with the medical uses of X-rays. X-ray light is energetic enough to pass through our skin. Our calcium-dense bones absorb that light, blocking it from reaching the detector and creating a shadow. Luckily for us, X-rays from space don't make it through our atmosphere. But what that does mean is that we have to send X-ray hunting missions into orbit to detect this high-energy light. XRISM also needs special kinds of mirrors, which were built at NASA's Goddard Space Flight Center.
The type of the mirror is called a nested mirror. It looks like an X-ray can be directed.
Called a microcalorimeter, nestled in a refrigerator-sized container of liquid helium. Resolve will measure the small temperature changes caused when X-rays hit one of those pixels. To track such small temperature changes, Resolve's detectors must be kept extremely cold. That liquid helium cryocooler will keep the instrument at 0.05 degrees Kelvin. It's so cold, it is a fraction of a degree above absolute zero. Heat is simply a product of moving atoms. Keeping Resolve's detector that cold means